Section 1.3, solving x squared plus bx plus c equals 0 by factoring. Solving means we're trying to find what values of x will make this equation equal 0. One way to do that is by factoring. Factoring trinomials, basically we're changing a standard form trinomial into intercept form, or a combination of two factors. A simple factor would be like 10. Remember when we used the factorization tree way back, we find two numbers multiplied together that would equal 10. So it would be 2 times 5. So 2 and 5 are factors of 10. Well, we want to do the same thing here. We want to find two factors that when we multiply them back together using FOIL is going to equal what we started out with. Well, the first step in this, by doing this, is figuring out what the signs have to be. And we look at the last sign to do that. If this is a plus sign, then it means that both of these signs are going to be the same. They're either both going to be minus or they're both going to be plus. And you just have to look at the middle term to determine which that they'll be. In this case it's a negative, so we know that both of these have to be negative. The plus means they're the same. This means they're both going to be negative. Next, we know that using FOIL, when we multiply the first together, the first two terms, it's got to equal this. Well, in order to equal an x squared, we're going to have to multiply an x times x. That's the only way to get that x squared. We don't want to put an x squared here and a 1 here. We want to go ahead and split them. Okay? So the only other thing then is we have to determine what these two numbers are going to be. And we also know using FOIL that when we multiply the last two together, that has to equal this last number here. So these two values, these have to be factors of 20. Well, let's list those out here. We know that 20 times 1 is 20. We know that 10 times 2 is 20. We know that 5 times 4 is 20. Are there any others? I think that's it. Okay, as far as whole numbers are concerned. So we know we either have to have a 20 and a 1, a 10 and a 2, or a 5 and a 4. And because these signs are the same, it doesn't matter which one goes where. We can reverse them around and we'll still be okay. But the other key is we have to be able to get this middle term. And remember, to get the middle term, we multiplied the outside and the inside, and then we had to add those two together. So of these three combinations, which of them would give us a 9 if we added them together? Well, the only one that will do that is the 5 and the 4. So we know that one of these has to be the 5 and the other one has to be the 4. And it doesn't matter which one's which because the signs are the same. So when the last sign is a plus, these two are the same as what's in front of the middle term. Factors of the last number have to add up to the middle number here. And we're finished. Let's look at another one. X squared plus 3x minus 12. So here we have a minus sign instead of a plus sign. When it was plus, these were going to be the same. When it's minus, these signs have to be different. Because to get this last term, we have to multiply the last two together. And the only way to get a negative answer is to multiply a positive times a negative. So one of these has to be a positive and the other one has to be a negative. That's the only way we can get a positive times a negative to get a negative answer right here. Okay? X squared, still have x times x. Now this time we need to get a 3, and since these signs are different, instead of adding them together to get that number in the middle, because these signs were the same, we have to subtract. because when we do the outside, one of them is going to be a negative value, and the inside, the other one's going to be a positive value, and when you add a negative to a positive, you subtract and take the sign of the bigger number. So we have to come up with factors for 12, because this times this has to equal 12. So we know we can use either 12 and 1, 6 and 2, or 4 and 3. Now the other thing is, since these are different, we have to find the combination that when we subtract them, it's going to give us this number here in the middle. In this case, there are no numbers. 4 minus 3 is 1. That doesn't work. 6 minus 2 is 4. That doesn't work. 12 minus 1 is 11. That doesn't work. What that tells us is that this trinomial is not factorable. And sometimes that happens. Sometimes you'll run across one that it just doesn't work. Okay? Let's do one that I know will work. Let's go x squared minus 4x minus 12. Last sign is negative, so we know we're going to have a plus and a minus. X squared is x times x. 12 could be either 12 times 1, or 6 times 2, or 4 times 3. Since the signs are different, we have to subtract to get the middle term. 4 minus 3 won't do it. 12 minus 1 won't do it, but 6 minus 2 would get us the 4. Now what we have to be careful of is we need to have a negative 4. So the bigger of these two numbers has to go after the sign that we're looking for, in this case a negative sign. So the 6 has to go here, the 2 has to go here. Gives us our x squared. That would be negative 6x, positive 2x is negative 4x when we combine those, and then 2 times negative 6 is negative 12. So it does work. Now there's some special ones also that we can factor. This is called a difference of squares. Because difference, because there's a minus between them, and squares, because each of our terms here are both perfect squares. Because x times x will get us x squared, and 3 times 3 will get us 9. So these two have to be perfect squares. If you have a difference of squares, it will always factor into two sets of parentheses. One will always be plus and one minus, for the same reason that we had up here. If that's a minus, the only way to get a negative number here is to take a positive times a negative. Have an x and an x. These two numbers have to be the same. That's why this has to be a perfect square. So in this case, 3 and 3 would get us that. Just multiply this out to see how this works. X times x is x squared. X times negative 3 is negative 3x. 3 times x is positive 3x. And 3 times negative 3 is negative 9. And you'll notice when we combine these middle terms, they look alike, but one's plus and one's minus. So those are going to cancel each other out, and we're just left with x squared minus 9, which is what we started with. So that's why we have to use, this number has to be a perfect square. So these numbers will end up canceling each other out when we multiply that out. It's a difference of squares. It's the easiest type, in my mind, of an expression to factor. Another special type of, in this case, a trinomial that factors is called a perfect square trinomial. So it's a trinomial So we know it has to have 3 terms. Okay. And we're going to try to factor this like we did before. And this is called a perfect square trinomial. Notice the last sign is a plus, so that means these two have to be the same as what's in front of the middle term, so in this case they're both going to be plus. To get our x squared, we know that has to be an x and an x. Also, for this to be a perfect square trinomial, the first term and the last term have to be perfect squares. So x squared is a perfect square, 36 is a perfect square, 6 times 6 is 36. So if this works as a perfect square trinomial, those two things, those two parts have to be perfect squares. So we have our x's, the numbers that go here have to be the same, and it's going to be the square root of that 36, which is the 6 and the 6. The thing we have to be careful of, though, is we have to make sure we can get this middle term, because these two can be perfect squares, but it doesn't always mean it's going to work, because if the middle term doesn't work, then the whole thing doesn't work. It's not factorable. So to check it, we just need to check the outside and the inside. So the outside is 6x, the inside is 6x. 6x plus 6x is 12x. So it does work. So this would be the factored form of this perfect square trinomial. You could also write it, since those two parentheses are exactly alike, you could write it like this: x plus 6 quantity squared. So let's look at another one of those. Okay, first term is a perfect square, last term is a perfect square. 8 times 8 is 64, and then we have to check to see if we get the middle term. Since we know both parentheses are going to end up being the same, I'm going to go ahead and write it like this, and just write one of them with the squared. That's plus, so we know that has to be a plus. Y squared, it's just the square root of that. This value is the square root of that. Then we have to check to make sure the middle term works. And there's a shortcut to doing this. Notice up here we went outside 2 times the inside 2, and then we added them together. Okay? Well, a simple way to do this to check is multiply these two together. Y times 8 is 8y. And then just take it times 2, because you know there's going to be 2 of them. 6x, 6x, there's 2 of them. So y times 8 is 8y, times 2 is 16y. It's what we have, so that is correct. Okay, the last thing in this chapter is solving using factoring. When you solve an equation, you're trying to find the x value where this parabola, and remember these are all parabolas, where they're going to cross the x-axis, or find the x-intercepts. Okay? To do that, we're going to use what's called the zero product property. What the zero product property says is if we have two values, let's say A times B, and we want those to equal 0 when we multiply them together, either A has to equal 0 or B has to equal 0. One of these two values has to be 0 if we multiply these two together and make it equal 0. So when we have, for instance, a quadratic in intercept form, which is factored form, Let me put down 1. And we want to find the solution to this. We want to know what the x values have to be to make this side equal 0. Well, that means that either this parenthesis has to equal 0, or this parenthesis has to equal 0. So we're just going to make two equations out of those and set them both equal to 0 and solve for x. So we're going to subtract 2 from both sides. So x is going to be -2 for here. We're going to add 6. So x is going to equal +6. So our solution then is x can either equal -2 or x can equal 6. If we were to graph this parabola that was formed by these two factors, that parabola would cross the x-axis at -2 and at 6 on the x-axis. That's what we're trying to find when you solve. These are called zeros. They're also called roots, or they're called solutions. All three of those kind of mean the same thing. Let's do one more of those from the beginning. Let's say we have y equals x² minus x minus 12. So in order to solve this, we want to find when y is equal to 0. Well, we need to factor this first. It's a trinomial, so let's see if it factors into two binomials. The last sign is a negative, which means we're going to have a plus and a minus. The first terms are going to be x and x, because x times x is x². The last terms have to equal 12 when we multiply them together, and also when we subtract them has to equal -1. So we have 12 times 1, we have 6 times 2, or 4 times 3. Well, the only one when you subtract would equal a 1 would be 4 and 3. So those are the combinations that we're going to use. Where does the 4 and where does the 3 go? Well, we need to have a -1 in front of this, so the bigger number has to go after that sign. So we want a negative, so 4 has to go after the minus. The 3 then will go here. Now we can set this equal to 0. We want to know what the x values are when y is equal to 0. So that means that either this has to equal 0 or this has to equal 0. So x plus 3 equals 0, x minus 4 equals 0. Subtract 3, so x equals either -3, add 4, so x equals +4. So our zeros would be either -3 or 4. And maybe you notice something here. Notice that our answer here is just the opposite of what that number is there, and the answer here is just the opposite of what this number is here. And you can do that. Let's say, for instance, I had these two factors, and I wanted to know what the solutions or the zeros are. Well, if you just take the opposite, so this would be x equals 10, the opposite here would be x equals -9. So these would be the solutions to those to that quadratic. This is where the parabola would cross the x-axis. It would be at 10 and -9.